Well, hi there, boys and girls. I've got this document up on assignments on Edline, so if you want to go grab a hold of this and download it to your computer, that would be fine. Or print it off, or you can just write this down. There's not going to be a whole bunch of writing. And so we're going to do solving right triangles. We'll just jump right into this. We're going to find missing sides and angles. And whenever you solve a right triangle, this means you are finding all missing sides and missing angles, and you will be given some of them. Now there's going to be 3 sides and there's going to be 3 angles, one of which will be a right angle, so that will be pretty easy. So let's just go ahead and do this example. I've got this picture of a ABC triangle, and I'd also like to go ahead and tell you that this little a is across from angle A, and that's always the case. If you see that they say side length A, that's always across from angle A. And side length B is always across from angle B, and side length C is always across from angle C. Alright, so let's grab a hold of this picture and a couple of examples. Let me show you how to work this stuff. So let's do the first one. If B is 5 and measure of angle B is 38 degrees, we're supposed to solve the triangle. So that means we need to find all of the missing pieces. Now the easiest thing would be the measure of angle A. Since we already know that angle C is 90 degrees and angle B is 38, so we could add those two together and subtract from 180. So 90 plus 38 is 128. And if we subtract that from 180, we get that that is 52 degrees. So we already know the measure of angle A. What are we missing? Well, we're missing side length C and side length A. I'm going to leave side length C for the Pythagorean theorem, but let's find side length A. So we are looking for side length A. We want to know what that is. We know this reference angle 38 degrees. We know the side opposite from the 38 degrees, and we're looking for the side that's adjacent. So what I'm going to do is write a little trigonometric ratio. I'm going to use the tangent of 38 degrees. The reason I use tangent is because I know the opposite and I'm looking for adjacent. And from SOHCAHTOA, tangent deals with opposite and adjacent. So the tangent of 38 degrees would have to equal the opposite side 5 over the adjacent side A. So let's go ahead and cross multiply here, and I'm going to get that A is equal to 5 divided by the tangent of 38 degrees. And so what I'm going to do now is go grab my calculator and figure out what that is. So turn it on. I'm going to do 5 divided by the tangent of 38, and I get that that is 6.39971. So we're going to call that 6.4. 6.4. Now that you have side length A, you can use the Pythagorean theorem to find side length C, and I'll let you do that, and you don't need to see the Pythagorean theorem again. Alright, so there's that example. I'm going to erase this, and I'm going to go, don't worry about this, you could just rewind it, you know, if you are worried about losing those numbers. So now we're going to work a different example. What if we know 2 side lengths, but neither one of the 2 acute angles? So if A is 4, it's across from angle A, and if C is 15, we need to solve the triangle. Well, I'm going to do the easiest part first, and that's the Pythagorean theorem to find side length B. So I would say that 4 squared plus B squared equals 15 squared. So 16 plus B squared equals 225. So B squared equals 225 minus 16, and that works out to be 209. So B is going to equal the square root of 209. I guess I could grab my calculator and see what that was as a decimal, but I'm going to keep it as the square root of 209 for now, because that's an exact answer. So let's find the missing angle. Let's find angle A. So I'm going to look at angle A, and I'm going to set up a trig ratio. I know the opposite side from A, and I also know the hypotenuse. So, and I know the adjacent as well, but I'm going to use what's given to me. This was opposite and this was hypotenuse. Now what trig function deals with opposite and hypotenuse? That's sine. So I will write down that the sine of angle A equals the opposite over the hypotenuse. Now, we learned yesterday in class that to find a missing angle from a known sine, we are going to find that angle A is the arc sine of 4/15. That's how we're going to find a missing angle. Arc sine will give us that missing angle. So we're going to go to my calculator, and I'm going to do the arc sine of 4/15, and that will give me the angle measure. And that looks like it's 15.466. So we're going to call that 15.5 degrees. And then, of course, oh wait, that's the wrong angle. We're talking about angle A up here. So I would say the measure of angle A is 15.5 degrees. So, of course, we could subtract 180 minus 90 minus 15.5 to find the measure of angle B, and we've got the triangle solved. All right, I want to get some vocabulary out of the way before we end this, and that's the angle of elevation and depression, because we're going to do some word problems. And when you're dealing with the angle of elevation and depression, you're going to find out that they are going to be the same measure. They are always the same. And the reason they are the same is because those are called alternate interior angles. Some of the questions will deal with angle of depression, and some will deal with angle of elevation. So you'll just have to look and see. Angle of elevation is the angle that makes with the ground. Angle of depression is the angle a flying object usually makes with a horizontal line that's parallel to the ground, and they're equal to each other. All right, so let's go work a problem here. All right, a flagpole casts a 60-foot shadow when an angle of elevation of the sun is 35 degrees. Find the height of the flagpole. So we'll go ahead and set up a picture. This will be my flagpole here. And that flagpole casts a 60-foot shadow. So this shadow of the flagpole is 60 feet. That's that one little tick mark stands for feet. And the angle of elevation of the sun is 35 degrees. That goes right here with the ground. And we're supposed to find the height of the flagpole. So I'll put a Y right here. So let's see. I have an angle, a reference angle. I'm looking for the opposite side, and I know the adjacent side. So I'm going to set up a tangent equation. The tangent of 35 degrees is equal to opposite divided by adjacent. And to solve this for y, I'm going to multiply both sides by 60. So 60 times the tangent of 35 is equal to that length. And so let's go type that in on our calculator. 60 times the tangent of 35 degrees. And we hit enter, and we get 42.01. So this is 42.01 feet. And that's your answer. And I will see you guys tomorrow.